All right, today we're going to talk about our systems, but now we're going to do word problems or applications. So there's a lot of steps in here to doing word problems with linear systems. So first we need to define the variables. You can use variables such as x and y. I like to use variables that make sense to the problem, but whatever works for you as long as you understand what you're solving for. Then you're going to write equations to represent the situation using the variables you defined. Then you're going to solve the system. You could do graphing, substitution, or elimination. Truthfully, we're probably not going to do graphing. We're going to do one of those methods. And then we're going to say, or after we solve it, we're going to ask ourselves, does this answer make sense? And then what do the numbers represent? So if we did our let statements here at the beginning, we should know what we're solving for. All right, so let's go ahead, let's get started. I kind of wrote all over, but I'll try to point you in the right direction as we're going. But for example 1, it says the admission fee at a small fair is $1.50 per child, $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. So we're looking how many children and how many adults attended. So that is where our variables are going to come into play. Now, I did C for children and A for adults. You could have easily have done X and Y as long as you've labeled what they represent. All right. So let's go ahead and let's think about how to set this up. You want to think about how the information is related. So in this case, all of this information has to deal with money. And this information has to deal with the number of people. So let's go ahead and I did $1.50 per child and $4 for adults. And I know those two are going to equal the cost of $5,050. So now let's look at people. Well, for the number of people, it just gave us this number. But don't the people include children and adults? So children plus adults equals 2,200 people. So now that we've got our equation set up, now we can start to solve this. You could do this by elimination. If you did this by elimination, you would multiply to get something to cancel. I probably would have multiplied this by -4 to get your A's to cancel. But I did substitution in this case. So what I'm going to do is I'm going to get A by itself. So I came over here and by subtracting C. So I've got -C. So now I'm going to use this equation wherever I see A. So I'm going to look here and I'm going to plug that in for A. So I rewrote the first equation, but instead of A, I'm putting that instead. So $1.50C plus 4. And remember, with A, we're putting parentheses around it, plugging that in, and then equal 5,050. So now go ahead and distribute the 4, and you're going to get -4C plus 8,800. Bring the rest down. We're going to combine our like terms to get -2.5C. And then now we're going to move this to the other side so we can solve for C. That cancels, and I've got -2.5C equals -3,750. Divide both sides by -2.5. And we have that C is 1,500. So that C is your child, so we know we have 1,500 children. But we need to find out adults also. So to do that, we're going to plug in, wherever we see C, we're going to plug in this instead. And I'm going to go with the easiest equation. So you can use this equation. You could also use this equation. Just remember when you substitute and you put it there. But I'm going to go with this equation so I don't have to worry about that negative. So what I did was instead of C, I wrote 1,500, and now we're going to solve for adults. So subtract, and I'm going to get A equals 700. So your final answer is 1,500 children, 700 adults, and that makes sense because we have a lot of children and we have not as many adults, but if we plug it in and we go back and we were to go 150, it should equal the total there, so you can always check it. All right, so now let's go to the next one. I started this, you're going to complete it. So again, we've got example 2. We're going to think about how information is related and make equations based off of that. So it's placed 2 orders with the nursery. So the first order was 13 bushes and 4 trees, and that was the total. The second order was 6 bushes, 2 trees, and that was the total there. So the bill does not list the price per item, so we want to know what's the cost per bush and per tree. So since we're looking for bushes and trees, that's what our variables are going to be. And in this case, I did X and Y. I could have easily done B for bush and T for tree, whatever works for you. All right, so the first order, it gives us bushes, trees, and a cost. So how my information is related here is all from the first order. And so I did 13 times the cost per bush plus 4 times the cost per tree, and this was the total we spent. And then the second order was were 6 bushes times the cost for, let me rephrase that. 6 times the cost per bush, and then 2 times the cost for a tree for $232. Now, you could solve this doing substitution, or you could do elimination. Whichever way works for you. Truthfully, for me, I think elimination would probably be the best, and I would try to get my y's to cancel. So I would probably multiply this by -2, and then that will get your y's to cancel out. So you're going to finish this, but if you do it correctly, your bushes should be $23 and trees should be $47 each. All right, so now let's go through, Example 3, we've got 2 different credit cards. We've got card A, which charges $75 per year and 15% interest off your balance. Card B charges $15 per year and 18% interest. So we want to know what would the average balance be for the cards to cost the same amount. So that means we're going to equal them to each other. So first let's translate. Card A is 75 plus 15%. So remember, we write that as a decimal. Interest on the average balance. Well, since we're looking for the average balance, that's X is going to be what we're looking for. So I set it up that way. And then for card B, I have $15 plus 18%. And remember, write that as 0.18. And then, like I said, we want them to be the same. So we're going to take both of those cards and equal them. And in this case, we already did like a substitution for it. So I'm going to go ahead, I'm going to subtract, kind of did a couple steps in one here. And then that's going to get this to cancel. I'm going to move the 15 over here, and that's going to get that to cancel. So I'm left with 60 equals 0.03x. Divide both sides. And then that simplifies to x, and you're left with x equals 2,000. Now that you know what 2,000 is, this 2,000 is your average balance. So that's your final answer. All right, number 4, I definitely want to do, because this is one where kids get stuck all the time. One, they don't realize the value of coins, so they forget nickels are 0.05, dimes are 0.10. You should know a penny is 0.01, a quarter is 0.25. So just make sure you understand the value. I'm going to kind of scooch this over here. There you go. So just make sure you understand the value of the coins, because that's usually where it gets kids mixed up. So Ken has 25 coins in nickels and dimes. and it's a total of $1.65. So we want to know how many of each coin. So we're looking for nickels, we're looking for dimes, so that's what I made my variables. Now you could have made this X and Y, but I thought nickels and dimes would be appropriate. So when we're setting this up, it really only gave us two numbers to deal with. So there's a lot of inferred information. So inferred information means this is just stuff that you need to know. All right, so we need to know nickels are 0.05, dimes are 0.10 or 0.10, so that's their value. So we're going to make one equation that has to deal with the value of it. So we know nickels are 5 cents each, and we know dimes are 10 cents each. So we're going to add those together, and then since this is dealing with the value, we want to use the money that goes here. Now, I know I have 25 coins. Kids know something needs to equal 25, but they always forget this step because the coins are made up of nickels and dimes. So you want to go ahead and you want to add your nickels and dimes together because this is how many coins they have. Now, what I did is, again, you could do elimination with this one. You could do substitution. I did substitution on this one. So what I did is I took this equation and I'm just going to rewrite it to solve for D. So I'm going to subtract N. And I'm going to get dimes equal negative N plus 25. So now that I've rearranged this one, wherever I see dimes in this first equation, I'm going to plug that in instead. So I took my first equation and I rewrote it. But remember, parentheses, and then equals 25. So make sure you distribute. And now we're going to combine like terms. And then once we've combined like terms, we're going to move this to the other side by subtracting. And so I've got negative 0.05 nickels, or times nickels, 85. So now I'm going to bring that over here. I'm going to divide both sides by negative. And then I'm going to get N equals 17. So that means 17 nickels. Now that I know I have 17 nickels, I can substitute it into either equation. This equation's probably easier. So I'm going to substitute 17 into this equation, which is what I did right here, and then subtract 17. I'm going to get D equals 8, so that means 8 dimes. So we've got 17 nickels and 8 dimes is your final answer. So again, remember that inferred information, and you want an equation doing with the value of it and the number of coins. All right, now this one I started for you. You're going to finish. All right, but how we're going to set up this one is Kelly bought 2 hamburgers and 3 orders of medium fries for $16.75. Jack bought 4 hamburgers and 8 orders of fries for $36.63. We want to know the cost of a medium order of fry. So we're really only solving for fries. So the strategy would be if we eliminate hamburgers, only fries are left. So I did, since it gave us information on hamburgers and fries, I did H for hamburgers, F for fries. Again, you could make this X and Y. It'll be the same. So I did one equation for Kelly. And then I did one equation for Jack. And Jack got 4 hamburgers, 8 fries for $36.63. Now, in this one, if I want to eliminate the hamburger, I would suggest multiplying the top equation by -2. That's going to get your hamburgers to cancel out. So you're going to finish this problem, but if you do it correctly, the medium fry should be $1.57. So remember, you want to think about how information is related, set your equations up that way, and then that is applications of linear systems.